prompted you to get into this field and take the amount of time that it obviously takes to earn all these degrees to gain the knowledge to be able to work at this?
Being stubborn. So I trained as a physician and as a researcher, and I was just motivated to help patients. So help them by figuring out what causes their diseases and try to dig deep into what the actual origin is so we can try to fix it.
And the thing with RP and other, obviously, autoimmunity disorders is sometimes when it isn't a known treatment path, when there's not a known cause cure scenario, sometimes the patients don't even know that they've got a particular disorder. They just put it off to something else. You must have seen that numerous times. Was that a motivating factor?
Yeah, I mean, it can be very challenging for patients not to have an answer, not to even have the beginning of an answer, let alone a treatment. So just to start the process of giving a diagnosis is the beginning of the road towards helping them. So definitely that was a part of the picture, is providing some kind of a roadmap forward.
And when you're dealing with something that there is no prescribed roadmap and knowledge, is that where sort of the interdisciplinary approach to things comes in? There's this great new partnership with the NYU Grossman School where you are, and with the Texas, I believe, MD Anderson Cancer Center, taking stuff that has been developed in terms of research protocols for cancer, can have a great application, modified maybe a little bit, for other things.
Yeah, so taking a fresh look at things, not doing the same sort of studies that have been done before and just looking at sort of what's going on with the immune system. What we're doing is trying to look at the genetics, what our genes are doing and maybe causing for these autoimmune diseases. I think that's kind of a new look for autoimmune diseases, and it's been very beneficial for relapsing polychondritis, and we're hoping it'll be broadly beneficial for other diseases too.
Well, it's, obviously this has been a battle that's been going on for a little bit, and getting those small wins when you start to find stuff. But when you can sort of cross-pollinate, if you will, and use some of that, that's sometimes you have to go outside the box in terms of not just the thinking but the approach. Absolutely, yeah, because we exceed, you saturate what you can learn from one approach. Trying something else and looking at it from a different perspective can be very helpful. And so, a lot of times, especially for relapsing polychondritis, there was no idea that it could be caused by genetic mutations. That's something that, that either people are born with, or that it's a change that happens in their genes. And so that was the new look that we performed, and that's what we're hoping to do more of with our collaboration with MD Anderson. Try to look at the genes to see if we can find the answers. Well, and I've heard that there's been a lot of excitement about the discovery, if you will, of, I think it's called the UBA1 mutation. That obviously is generating some real energy here, isn't it? Yeah, so I was part of a large group that helped identify this genetic cause, mutation, that leads to autoimmune diseases like relapsing polychondritis. The hope is that now that we have a cause for some of these patients, we know where to target our efforts, where to look for treatment, where to look for how to stop this disease. And we're hoping that we'll find more of these in the future. In these discussions, we hear the phrase, that if we can find a biomarker, if we can explain what a biomarker is. So a biomarker is something that we can either think about targeting for treatment or targeting as a way to monitor for disease progression. And the idea is it could be clinically useful. So let's say we had something that showed elevation when someone needed more treatment. We could maybe predict that they're going to need more treatment. We could have something that we can target to stop progression disease. So it's not clear yet if UBA1 is a biomarker, but it's at least the cause of all the problems. And in some ways that's more important, because it's actually where, if we could solve that problem, we will solve some of these patients' diseases. Yeah, be able to give them a treatment, certainly, and hopefully eventually a cure. Absolutely, and we don't know why UBA1 causes these diseases, so actually figuring out the signaling in the cell that leads to the disease will be critical for helping these patients. So we're hopeful that this is the beginning of a process of having new avenues for treatment, new avenues for hope. Race for RP, let's talk about that a little bit. Obviously, I think it's, I've been in racing a long time. I've seen charities that have become involved in it, but using that absolutely passionate, intense fan base in racing
to help raise the awareness and then help drive education, and now starting to work on generating funding for research, is an absolutely great program. And again, a little bit more outside of the box thinking to be able to find these unique things. And I know that stuff has been propagating already. I mean, there's National Institutes of Health is now on board working on some things. It's been productive, hasn't it?
Absolutely. I think it's same sort of out of the box thinking. I don't know, racing and science don't immediately come to mind, but the fact that we can bring more attention, bring more support to these devastating diseases is critical. And they're supporting my research, and I think we're out there trying to help patients. So I'm tremendously thankful.
My name is Nancy. I'm a patient with relapsing polychondritis, or RP. RP is an autoimmune disease that attacks cartilage and, if untreated, can be fatal. To drive awareness and accelerate research, we established the Race for RP. Success on the track has opened doors to world-class healthcare providers, researchers, and autoimmune disease experts, leading to groundbreaking discoveries and new hope.
We are driving awareness and accelerating research in the Race for RP.
Well, and I think, racing and chemical science maybe doesn't necessarily go hand in hand, but, but racing and physics, that's very much hand in hand. And on some level, science is science. So I think you get those people that are tuned into the physics science of motorsports. It's not a huge step for them to be able to go, I can see what you're talking about on the chemical research side of things.
Yeah, and I think a lot of clinical medicine is not precision. It's based on lumping things together and thinking that patients may respond to a certain treatment. But genetics and what we're trying to do is actually getting at the precision, the precise cause for the disease. And I think that maybe that's some similarity with what happens with these very loud machines out there.
Hey, you've been in and amongst them, have you? This is your first visit, from what I understand. And you spent the morning in the paddock and, wandering around getting some experiences. You're going to be in for a real treat when you actually get a ride around here that I understand
or terrifying,
is set up. Well, let me tell you, Didier Taze, who I understand you might be getting the ride with, one of the greatest drivers in his prime. I don't know what he's like now, but he was brilliant in his prime. So you'll be able to have a lot of fun. And I'm kidding, of course. He's the head coach for the entire Ferrari Challenge program. He's as good as it gets. But that's the element. The other element of Race for RP is to give people like you the chance to come get, into one of the seats of these cars, get a lap, get a feel for what just drives these passionate fans, and be able to use that passion, momentum, energy to further the cause.
No, I think the enthusiasm that I've seen while I'm here for racing sport is amazing. It's great, and to kind of harness that towards other goals and RP in some cases, it's wonderful. So, and I've seen other causes here too. It's nice to see.
Obviously we talk a lot in racing about the excitement about it and everything. From your perspective as a researcher, what's an exciting moment for you in the research world, and what's a recent one where you've kind of had one of those aha moments that really has lit you up?
There's two kinds of aha moments: when you solve a problem, or when there's a really important problem ahead of you, right? And that's going to be years of a challenge. Right. And so some of the aha moments, a recent aha moment is just making diagnoses for patients in clinic and changing their treatment, just knowing that we can put a name to what they have. And that happened this week. That happens on a weekly basis. So, but I think that part of the reason why I like research and science and clinical is that you can actually what the challenge is. It's right in front of you.
Right.
Trying to help these people, right? And so sort of trying to rise to the challenge, right? And hopefully doing it more and more throughout my career.